XenomatiX is a leader in true solid-state LiDAR technology. The Xenotrac 6D road scanning system helps engineers, surveyors, and inspectors by delivering a complete 6D digital twin of the road. Xenotrac replaces time-consuming visual inspections and reduces cost by allowing road authorities to quickly and more accurately analyze the surface for roughness, cracks, potholes, and other damages. With its fast and simple installation, Xenotrac can be mounted on any fleet vehicle, anywhere, anytime. In under an hour, and with the push of a button, city officials can begin gathering the data needed to determine which areas should be prioritized for repair. Here's how it works. Available in single and dual-lane applications, Xenotrac establishes the three-dimensional geometry of the road surface, calculating the International Roughness Index and Rutting Quality Index. Xenotrac can accommodate all road surfaces, including concrete, asphalt, and cobblestone. Only one driver is required to collect and view the data, which can be obtained at both higher and lower speeds. Xenotrac leverages a millimeter-accurate 3D geometric twin and high-resolution 2D camera images. In a single pass, the entire road is digitized, and any index or quality parameter can be calculated according to local or international standards. Xenotrac also detects and logs important road and lane markings, like arrows or painted messages on the ground, with accurate geofencing, thanks to real-time kinematic positioning. After completing the drive, road maintenance personnel can take the data back to their workstation for further review and evaluation. The data transfer process from Xenotrac is simplified to maximize productivity for surveyors. After processing and all quality features are calculated, the data is ready to import into a personal pavement management or geographical information system. Our engineering team meets with customers to examine the data and provide additional support. With Xenotrac, customers can prioritize and budget for critical road repairs, saving time and long-term costs. At XenomatiX, our mission is to provide road safety and comfort with reliable, versatile, and affordable true solid-state LiDAR.
Hello everyone, welcome to Surveying Group News. This is Emrah Deniz, and thank you for all joining us for today's webinar, Efficient Road Inspection with 6D Road LiDAR, brought to you by SGN and sponsored by XenomatiX. Just a quick reminder, please do enter your question on the chat box. At the end of the webinar, we will run a Q&A session. And also, you can always contact XenomatiX through info@xenomatix.com. The webinar is being recorded, by the way, and you will receive an email from us in the next few days, including the recorded webinar. Finally, let me welcome to speakers. We got Kris, the Meester, who is the Vice President of Business Development and Sales at XenomatiX, and Yannick Lefebvre, Account Manager at XenomatiX. Welcome, Kris and Yannick. How are you?
Very good, Emre. Thank you.
Thank you.
Yeah, good to see you guys, and I can't wait to hear more about 6D LiDAR. Let's start, please.
Okay. If you can share the screen, Emre. Okay, welcome from our side, everybody. Thank you for joining this webinar. The audience that we target are the road authorities and road surveyors, and particularly the ones searching for high flexibility and high productivity. And as an extension, we also target contractors, road construction companies, and even road construction equipment manufacturers. At the end of this webinar, you will have gained ideas on how to improve your productivity in pavement management by looking at different kinds of data you need in your management platform, at the kind of road data that facilitates pavement management, at the frequency of data collection required, and at the new technology allowing productive data collection to start with. For the contractors amongst you, you will see new opportunities to progress in virtual design and engineering of the roads. You will see the potential savings on material and preparation costs and get some ideas on how to assure first-time right construction or reconstruction. Let me start with an example. Here you see the pavement management system from a larger city in Belgium. They started some months ago with this new pavement management, and here you see a section of their road network. Data has been collected over all these roads, resulting in automatically and objectively calculated road condition measures. High road quality is then represented in a green color, so good color, medium quality in yellow, and the worst roads have received a red or even black color score. At this stage and in this example, the road condition index is the IRI, the International Roughness Index. It's a standardized and worldwide used road quality index. Let's zoom in on this street with the red and black scores, and let's zoom in further. Here you see the red score and the black score, the worst scores for the road condition, according, in this case, to the IRI. If you have orthophotos available in your geographic information system, you can check on the housing around the street with the bad scores. And when you zoom in further and you visualize the layer of the digital twin, the LAS file, you immediately see why this street got the red and black condition score. The digital twin is the three-dimensional geometry of the road. Since it is hard to present 3 dimensions on a flat computer screen, we give different colors for different heights. Green meaning flat road, so good. Blue and purple meaning subsidence, deficiency, lower level. And yellow and red for geometry sticking out, like bumps. Let's turn off the layer of IRI and focus on that digital twin. You notice that this street has many spots of subsidence and potholes. And also part of the road sticking out, yellow and red. Intuitively, you already have an impression why the scores of these two streets are bad. Zooming in further, we see manholes sunk in, a larger pothole, subsidence on the sides of the street, and the green-brown dots on the roads represent the positions of 2D photos taken. And we take photos every 5 meters as a standard. Opening one of those photos, we recognize the manholes, indeed, but it's much more difficult on 2D photos to recognize any geometry. It's hard to see on the photo that the manholes are indeed sunk in, or that the sides of the streets show irregular subsidence. The same can be done on other kind of streets. Here, for example, on a concrete slab street, where the slab joints are not fitting well, as you can see, causing the renowned dug noise and vibration, like in a train. You see the blue lines and the jumps in colors around the slab joints. Or a street in element paving, where wear is seen clearly on the picture, on the photo, but rutting only detected on the 3D digital twin. Zooming in shows the rutting. No need for a photo. And for people with experience, you can imagine the cause and even the repair and required cost. It's like you're measuring in detail on site, on the spot. Going back to the overview of the road network, the road condition is visualized intuitively with colors. To manage your budget, you check on the cost estimated to recondition each of the red and black roads. And if your budget is too small, probably you decide to start the red score for an IRI of 8 instead of 6, like here. And this way, you still keep your focus on the objectively worst roads. The objective measure and numbers remain, but it's up to you, the asset manager, to set your threshold, so align required works and available budgets. In the next section, we enlarge the measure of IRI to one that accounts for other important information to do productive pavement management. In the example, we presented the IRI as a measure to manage your road assets. In reality, the road pavement manager has to account for quite some more factors. The IRI is a valuable road roughness index, a road comfort or road quality index. But in case you decide you like roads that are by nature more rough, you don't want them automatically pop up in red and black scores. Cobblestone roads, as an example. They have by nature a high roughness. But some communities like cobblestones as heritage or even as natural incentive for the drivers to drive slowly. So it's an idea to weigh the road roughness index with a factor depending on the road surface, and this way align the quality of a cobblestone road to an asphalt road. Traffic intensity is another factor influencing your budget allocation for road reconditioning. Roads that many people use multiple times a day deserve more attention or earlier budget than roads that are rarely used. Another factor of importance in road pavement management is the existence of assets underneath the road surface, like water and sewage piping, like electricity or communication lines, and so on. How often have you seen a road repaired and a month later, workers breaking open the street to work on utilities underneath the road? Besides the planning in your asset management system, there's even a relationship between the condition of the road and utilities underneath the road. I remember one time we reported our road survey data to a community and pointed out a suspicious larger area of subsidence near to some manholes. The mayor requested the inspection of the sewage, and part of the piping turned out to be broken. So important underground damage, like important leakage, that causes subsidence in asphalt pavement. And therefore, we promote a regular road survey, not only to check road condition, but also to check the assets lying underneath the road. Another case, I don't know whether you remember, but we here in Belgium, we do. It's like 8 to 9 years ago, we had a kind of a big accident in a suburb of Brussels, the capital of Europe. A public transportation bus fell down in a major hole in the middle of the road. A leak in the water conduct had eroded the road foundation, but the pavement kept up until it couldn't take the weight of a fully loaded transportation bus. People were injured, and the road was closed for over 6 months. It was really a major political crisis at the time for the Brussels government. The lessons learned is that regular road surveys can prevent accidents like this. And another assets like vegetation also play a role in road condition degradation. So here the key message is that productivity is enhanced if you gather related assets in one and the same platform. Now, how often do you need to survey the roads for a productive road asset management? Every year? Every 2 years? Or 3 years? We work closely together with the Belgian Road Research Center, and scientific research has proven that it is economically beneficial to measure and repair regularly compared to letting the road degrade and having to do more expensive repairs later on. Scientifically proven. So there is an optimum to minimize the sum of survey and repair cost, and that favors regular condition survey. We even have a customer that measures his road network of thousands of miles twice a year, one time before winter and one time after the winter. And after the latter survey, that customer immediately defines the required works to execute over the summer period with the sole purpose that the impact of the next winter remains limited and that he minimizes his repair budget over time. But you don't only measure for follow-up of your road condition. You also measure to check, of course, the quality of the contractor's work just finished. Let me tell you a nice story, or maybe not so nice story. An intercity road showed worn concrete slabs, resulting in lots of traffic noise and discomfort for the commuters and the neighbors. A year before election, like often happens, the council decided to renew the worn concrete slabs. The works were executed and the works were delivered, inspected and accepted. Less than a month later, complaints from people were accumulating. Horrified they were that the condition of the road was worse than before. We measured the road and identified indeed that the IRI on the location of the new concrete slabs was very poor. Looking at that photo, however, I see no harm. Can you? But when you take aside the digital geometrical road, we see clearly the lateral grooves. Remember the geometry colors. Green is flat, blue and purple is subsidence or lower level, and yellow and red is sticking out on top higher surface. So the lateral grooves show a kind of washboard in the driving direction. The flattening of the concrete was done manually with a ruler, and that's allowed by contracts most of the time, but the concrete was too dry and hence was sticking to the ruler that was pulling away concrete material, creating grooves. So not only does the 3D show you the damage, it often indicates the cause, and you don't have to be a road engineer to see that. And it's actually such a case that motivates contractors to use the same concept for measuring the new paved road during the paving process itself. Some road pavement equipment manufacturers are even developing solutions to monitor and control the work ongoing. And although some will disagree, but the most gain of your productivity is that you can check, analyze, combine data from behind your desk. If you have a fast and accurate road survey and you get comprehensive and processed data on your desk, you can spend your time with the interpretation of the data and with managing your assets and taking sound decisions. What do we mean with comprehensive data? Well, we promote from our side the 6D digital twin. The 6D stands for 6 dimensions. 3 dimensions for the geometry of the road surface, 1 extra dimension to include road markings, and then additionally high-definition photos every 5 meters, as I mentioned before. The data is captured independent of the road type, what accuracy allows to correct calculation of standardized indices like IRI or evenness coefficient for any kind of surface. Here an example of a cobblestone road, and when we zoom in, you see the detail of each of the cobblestone, with the joints in between the cobblestones somewhere more widespread than at other positions. And again, also the intensity information on this road, there are no markings. And this brings us back to the beginning of the presentation, the pavement management platform with the color representation of the measured geometry of the road markings, and the related georeferenced photos. All this is already in place for quite a while. Let me tell you why we need a new dual lane road lidar, the dual lane Xenotrac. For those who are not familiar with the single lane Xenotrac, a short refresh. The lidar with the white housing is a single lane Xenotrac. The one with the gray housing is a dual lane Xenotrac. The lidar sends out 28,000 lasers to the road surface, and the reflected invisible infrared light is captured by the other side of the lidar. Above the receiver of the lidar, you see the high-definition camera mounted for the photos every 5 meters. And all equipment is linked to an RTK GNS IMU with dual antennas for synchronization and aligned georeferencing. As long as the vehicle does not move, the 28,000 lasers measure the same points on the surface. It's when the vehicle starts driving that the lasers scan the road surface and that the same point on the road is measured multiple times, resulting in millimeter accuracy of the road geometry. And the single lane road lidar is already very productive. And one of the unique features in that concept is actually the onboard post-processing. The controller collects the raw data from the sensor and forwards the individual point cloud frames to the processing unit. The processing unit combines all the data to one digital twin of the road while driving, and even starts taking sections and calculating measures like IRI, evenness, or rutting. So this means by the time you come back home from a full week of serving, as an example, your post-processing is already well advanced and probably even finished. But okay, those are already features for the single lane. So the question remains, why do we need the dual lane? Well, for multi-lane roads. For multi-lane roads, you have to drive the road multiple times. And after the data collection, you still have to stitch the data of lane 1 to lane 2 and so forth. And while some customers have the algorithms and the knowledge to do this stitching, it still remains a tedious and time-consuming job. The same accounts for surveys of runways on airports. The last project we did, we had to drive 15 times back and forth to have the full width of the runway captured. It only took us 2 hours, but anyway, with a dual lane, we literally save half of the time. With the single lane Xenotrac in the market, the request of the dual lane came actually from customers, eager to increase their productivity even further. Also, the idea of the dual lane mounted on one side of the road, measuring the lane you drive and the neighboring lane was launched. On this picture, you see the single lane and the dual lane aside, the single lane with the white housing on the right and the dual lane gray housing on the left. Notice the difference in mounting. The single lane mounted in the middle of the roof and the dual lane mounted on the side of the roof. Especially for road authorities and road surveyors that specialize in highways and multi-lane roads, the productivity is increased drastically. And it gives opportunities also to get more detailed insights of the full highway. Today, often only the slow lane of a highway is measured for reasons of time and required speeds on the left lane. With the dual lane system, you can drive on the middle lane and collect the data for the middle and the left lane. Or when you drive on the slow lane on the right, like you do today probably, you also capture the road conditions of the middle lane. So more data to decide whether the full highway needs reconditioning or only the right lane, or the right lane and the middle lane, but not the left lane. So this way, besides saving on time for the data collection, you can also save on the contractor work. But probably the contractors in the call would not like this suggestion. By the way, that specific customer that measures the thousands of miles of his road network twice a year is a customer of the dual lane system that you can imagine. The output of the dual lane is completely similar to the output of the single lane with the 3D geometry of the road markings, and then the aligned georeference to the pictures. It's not a purpose to discuss individual specifications one by one. As you see here, the difference between the single lane and the dual lane is concentrated on the width of the road measured. 7.5 meters instead of 4 meters for the 7.5 meters for the dual lane instead of 4 meters for the single lane, and a slight difference in accuracy and resolution. For those who are interested, please reach out so we can share the full spec sheet and, if required, explain in detail. The main point of this webinar is to talk about productivity. Let me summarize in 5 points the gain of productivity with the Xenotrac system. Point 1, the system can be set up quickly and easily on any vehicle and can be swapped from one vehicle to another. You might have seen that in the introduction video just before this webinar. Point 2, the road lidar Xenotrac digitizes any road at speeds up to 90 km per hour. Above that, you might have some blur, so up to 90 km perfect data, and you can do so day and night. Point 3, post-processing is started on board while collecting the data. The data are highly accurate and with a high resolution, more than most will ever need. And then finally, the new dual lane system can further increase your data collection productivity with a factor of 2. We're already at the end of the webinar, so time to wrap up. For the road authorities and road surveyors, you have seen the importance of assembling all related data in one management system. You've seen accurate and objective data, intuitively visualized and practical to use in your decision making. I hope I convinced most of you of the importance of regular road surveys to actually save on your budget over time. And last but not least, for productive pavement management, you need productive and affordable equipment to collect the data and process the road conditions indices. For the contractors amongst you, I try to give you hints for opportunities towards advanced virtual design and engineering of roads. And that advanced virtual design and engineering will result in savings in material and preparation costs. And that gives perspectives for another productivity increase by measuring the paving quality during the paving process. And if you want to remember just one, let it be the point that productive and affordable road lidars like the dual or single lane Xenotrac will save you money in the short term. Feel free to reach out to any of my colleagues or to any of our partners worldwide. And now it's time for Q&A. So I ask Emre to help me ask the questions.
Yes, thank you, Kris. It was really impressive presentation and impactful, I think. Yes, we are waiting your question now. If you have, please use the chat box where you are now, which social media channels you can send your message to us.
I have received one question here already, Kris. We can get started with that.
Okay.
So you mentioned that the accuracy of the 3D digital road is millimeter accurate. What is the accuracy of the geopositioning of the 3D digital road and the road markings in worldwide coordinates?
Okay. So the accuracy of the geopositioning with the RTK, and I specify it's with the RTK, real-time kinematics, GNSS and IMU, is getting to a few centimeters. So you never can have with, even with total stations, the millimeter accuracy, but centimeter accuracy. And we've proven this in different projects, also for Google and Apple and large companies. So that's a fact. It's centimeter accuracy.
All right. Next question we received is, are those photos that you mentioned, are they also geo-referenced?
Question is the accuracy of the geo-referencing.
Yes, are they geo-referenced? That's the question someone asked here.
Yeah, so the geo-referencing is completely in line with that RTK. So the geo-referencing happens through the RTK signals fully aligned with the 3D and the 2D and the intensity information. So all of that data has the accuracy, including the 2D pictures, of centimeter precision. And the purpose is even that we, in our algorithms to process data, that we overlay the 3D data with the picture and the intensity. So we have 6 dimensions on which we can run algorithms, whether it's rule-based or artificial intelligence, to extract further information.
All right. Does the Xenotrac fit on any vehicle, and can I switch the system from one vehicle to another?
That's a good question. Actually, it is, and it's very specific for this system, for this road lidar. We have customers in the United States that fly with the system in their suitcase from one state to another. They rent a car, install the system in half an hour, 3/4 of an hour, and start measuring and collecting data with onboard processing. So any vehicle, the condition is that the system should be mounted at a height above the road surface of between 1.8 meter and 2.2 meter. But on any vehicle. Yeah.
Can the data from the Xenotrac be loaded in any GIS system, or are there limitations?
Ourselves, so we are kind of a server ourselves. One of our department is an internal customer, and the data that we provide is the purpose, as I presented in the webinar, to have an overview and not only have the road data available, but also data from vegetation, from sewage, and so on. And so we want this data to easily be imported in the geographical information system or in a platform from the customer. And so the standards of the formats, like LAS formats, is integrated, so it can be in one click uploaded to your system, whether it's QGIS or ArcGIS or GeoIT or any kind of a GS, a geographical information system. So that fits well, yes.
Another question, what are the road condition measures you can calculate with your system? And do you calculate those manually or automatically?
Whole webinar is about productivity, so I'll answer the second question first. It's automatically. What are the indices that we can extract from this 6-dimensional data? Well, first of all, with rule-based programming, since we have the full geometry, we just apply the formula of the IRI or the evenness or the rutting, that's a formula, mathematical formula, on that data to calculate those indices fully automatically. On top of that, we have applications for customers that extract just the lane markings or the road markings. So that is a 4-dimension. That can also be extracted and is part of the options to extract with our software automatically. And then you do have the 2D image, not only to have your comfortable feeling and looking at pictures like you're used to, but also to extract features. So for instance, we do extract today also crack information from the 2D pictures. We are programming to extract it from the 3D, but we can extract it already from the 2D. And then there are many other complementary suppliers that have algorithms to extract whatever from picture from camera images. And that is all the trend, of course, to do that all automatically.
Any more questions from the audience, or Amra, did you get any questions on your end?
I couldn't see any question now. I think there is no question now. Yeah. Okay.
Maybe let me share our contact information one more time. Hold on.
Sure.
So you can reach out to us for questions, or if you have some very particular specific questions for your application that you don't want to throw in the full audience, please contact us. You can contact us at info@xenomatics.com or any of those of my colleagues that you see on the slide here with the according email addresses.
Well, thank you, Kris, again, Kris and Yannick, and all our participations. Thanks for taking time, and see you again.
I think all the participants will receive a link to the recorded video.
Yes,
right,
yes,
Emre?
they will.
Okay.
They will get a recorded video, maybe in a few days, and also our social media accounts will be placed the video, and they can also add their further comments below the posted, and also Kris will answer, I think. Yeah.
Absolutely. We will follow up very shortly for the open questions. Thank you, everybody, for attending. Thank you, Emre, for organizing.
Yeah.
And hope to
Thanks
speak
for
to many of you soon.
Bye.
Have a great afternoon. Bye-bye.
Goodbye.